Right. First paper. This is the series from 2025, and we're doing our mensuration together. So if I see a question that I think we've talked about, we've discussed, then you're the ones who will do it, and then the ones that you need me to explain, I will do it. So we do it together, and I need you to practice. So I'm going to be hard on you a little bit. Let's move fast. We won't waste time. So this is 2025 series, all the 2025 papers. This is February, March 2025. And we know that, I think by now, I've taught you. Can you all hear me? Majita, can you hear me? All right. Make sure everybody who's in class, stay in class, please. By now, I've taught you that for February, March, for paper 2, it is only going to be 2-2. But then, sorry. It's only going to be 2-2. And paper 4, it is going to be 4-2. But when you go to May, June, for paper 2, we'll do 2-1, then we'll do 2-2, then we'll do 2-3. For paper 4, we'll do 4-1, then we'll do 4-2, then we'll do 4-3. This is for May, June. Oh, this is just May, June. Okay. Then we go to October, November again, and we'll have the same thing: 2-1, 2-2, 2-3, 4-1, 4-2, and 4-3. We'll be just doing mensuration questions. Mensuration questions. So we have more than enough. We have more than enough practice. We have more than enough papers to practice with until we kind of have an idea of everything. So let's go for it. Are you ready? Do you have your calculators with you? Remember, we do together. Do you have your calculators with you, everybody? Students, do we all have our calculators? Do you have your calculators? Okay, good. So make sure you help me with the calculation. If I ask you to help me, then make sure you help me. All of you. Not even a problem. So now let's do these, and let's see. May, June. No, we start with February, March. Paper 2-2. That's the only paper 2 for February, March. It's only 2-2 because it's written in one region only. The reason why you have 2-1, 2-2, 2-3 is for different regions, right? Different regions should write different papers because so that there's no cheating. Right. Let's go and look for a question. Give me a second. We want to look for questions of mensuration. Here's the first one. We scroll down. Let's go through it together. I'll be moving fast. We look for a question on mensuration. Here it is. They've given us a cylinder. So we're going to be revising whilst we are doing questions together. So I'm going to add a page right here and move it up. Okay. Good. Here's our cylinder. And remember, I told you that you have your cylinder is a container. Remember, you have your 2D shapes. I'll add more information. I have a lot of things to say, but I'll add it as we are talking together about these. We have 2D shapes, we have 3D shapes. Now, 3D shapes are the containers. Now, for the 3D shapes, you have your cylinder. Okay, these are the containers, students. The containers are the 3D shapes. You have your cylinder, then you have your pyramid, and you have your cone. I can say these are the main ones. These are the main ones. Okay, and I have work to do making everybody in here master. We still have a cuboid. It comes sometimes, but the ones I've given you are the main ones. Okay, you still have a cuboid. So on your cylinder, like this, and a sphere, by the way, and a sphere. Sphere also comes a lot. Okay, sometimes they bring it as a hemisphere, so you put sphere. Now your cylinder is like this, and what you must know is everybody must know this is the radius, this is the height. These are the two things you need. Once you have them, then you can use them in the formula. So you must make sure you have them. Once you have them, now you can use them in the formulas. Formula for volume is area of a circle times the height. The formula for volume is area of this, then you multiply by height. Then you have the surface area. The surface area means all the areas. Combine all the areas. We have the circle on top and another circle at the bottom. So we have two circles. So we say 2 pi r squared. Plus, we have the curved surface area of a cylinder. Okay, these are the two circles, the one on top, the one at the bottom. Surface area of a cylinder. These are the two things you gotta know, and you're fine. There's no way you struggle with a cylinder question if you know these. Surface area, you must know that these are for the two lids, the top and bottom. The two lids, okay, the top and the bottom. Plus, for the curved surface area, we said when you open your cylinder, like it was a circle like this, you cut it here, you open, you'll be able to make a rectangle, okay, with your cylinder. You'll be able to stretch it out and make a rectangle. Then this rectangle, you can fold it back to a cylinder. But when you make it into a rectangle, it was a circle when it was a cylinder. You have opened it up straight. Now, okay, it was a circle. Now you have opened it up. It becomes a rectangle here. And this rectangle, we said, this length was the one which was the distance right round the circle, which means it was the circumference of your cylinder. Now it's the length. What is the circumference? 2 pi r. Surely you should know that the circumference, which is the distance right round this circle here, is 2 pi r, which is the length. Then you multiply by height, which is this one. So it's going to be 2 pi r h. This is the curved surface area of your pyramid. So this is the curved surface area. All right. So do we know everything about your cylinder rather? Do we know everything about a cylinder? Yes, we're pretty confident. We are pretty confident. Bring it on. We have the important information. Now let's answer the question that comes in here. They've given us a cylinder, blah, 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 blah. Now, I've taught you many, many times, and you're not going to let me down right now, that there is always a line. Listen. There is always a line in the question that tells you what to do. So either it is going to say something about surface area or something about volume, so that we know what formulas we are supposed to use in the question. Because it's not abracadabra. This question is asking for R, but there is no formula for R. We did so many things about a cylinder. We saw that we only know surface area and volume. There's no formula for R. So we need to use the formula for what? We look here. The volume of the cylinder. Oh, volume. So we already write volume of cylinder. Did we do this question? This is equal to volume of sphere. So it is equal to volume of sphere. Now, for sphere, you should know the volume. Sphere is this ball. Radius. Volume of a sphere is 4/3 pi r cubed. Because they mentioned volume of a sphere. It's 4/3 pi r cubed. So, volume of a cylinder is equal to volume of a sphere? Yes. What's the volume of a cylinder? It's area of the circle on top here. Here, that's the cross section. Then you multiply by the height. So it's area of the cross section. What is area of a circle? Pi r squared. You multiply by height. So it's pi r squared h. What about volume of a sphere? 4 over 3 pi r cubed. Now, these two things have different radii. So if you use small r for radius of a cylinder, you should use big R for radius of a sphere. Now we have been able to convert this statement into a formula. Now we can find R. They said volume of a cylinder, we wrote it V of a cylinder is equal to, we put the equal sign, then volume of a sphere, we put it, then we can go for it. What do you know about it? We are looking for R, the small radius. So we're going to take pi and h to the other side. R squared will be 4 over 3 pi r cubed, okay, big R, divided by pi h. The pi's will cancel, okay? We could have cancelled them here because they were there on both sides, but we left them. So now we have it like this. 4 r squared will be equal to 4 over 3 r cubed divided by h. Now, since this is a 4 over 3, you can put this 3 in the denominator. So you have r squared be equal to 4r cubed divided by 3h. Wow, really? Yes. Which means to get r, you will square root 4r cubed divided by 3h, which is going to be the big square root of 4 times big R. What is R? Is the radius of a sphere. It's 3. 4 by 3 cubed divided by 3h, which is 3 by, what is the height? 16. Divided by 3 by 16. And what do you get? What is your R? Square root of, here, 4 by 27, because 3 cubed is 27, over 3 by 16. Then you do square root. So, somebody do it. Open bracket for these two at the top. 4 divided by 27, divided by 3 by 16, okay? Tell me what you get. Then you do square root of that. So you can now say then square root outside. Then you open bracket. You say open another one. You say 4 by 27, you close, then you close again. Divided by, open bracket, 3 by 16, close, whatever. Then you close this bracket for everything under square root. Tell me what you get for R. Tell me what you get for R. What are we going to get for R, students? What is it? 1.5 centimeters. Hi, Ashta Shingi. So it's 1.5 centimeters as your final solution. Anyone with a question here? Students, is there anyone with a question? Excuse me. Is there anyone with a question? Oh, you did not get 1.5. Okay, let's punch it together. For those who did not get 1.5, put your answers in the chat. Put your answers in the chat. So I'm going to say square root, then I open. So square root, then I open bracket. Then I'm going to say open another bracket. 4, then I open bracket. I say 27, I close and close again. Then I say divided by 3, open bracket, or I can say divided by, then I say open bracket 3, open another one, 16, close, then close again, then close the last one. Should be 1.5. It says the answer is 1.5. Did you all get 1.5? You should get 1.5 as your answer. Keep practice the punching. If you don't get 1.5, I want you to don't ignore it. I want you to practice punching, and you see. Look, you get 4 marks for this. Okay, for having 1.5 and writing it correctly, you get your 4 marks. So you get 4 marks for it. Right, let's go to the next. So this is going to be our first paper, February, March 2025, paper 2. Now we want to go to February, March 2025, paper 4. Okay, then we're going to go to May, June 2025, and it's just going to be like that. So it's easy. You just go through all the papers in the next 1 day or 2 days. You should be done with this. You should be done with this topic. You just go through question after question after question. And now I'm opening it. Let me share with you. We are going through the paper 4 for February, March 2025. Let's go for it. Okay, I'm going to be moving faster now. I think you are all getting used to it. So now I can move a little bit faster. All right, let me highlight all the papers I want to do. I'm putting it into the iPad. Let's see. Documents. All right. So now let's do it. Paper 4. Right. Here's the paper. We're gonna go through this also. We move fast. Let's scroll down. So this is February, March. Everybody can see. February, March, paper 4. It's 2 hours long. So it's last year's. Let's see. Shapes. We're looking for shapes where they ask us for earlier volume or whatever. Scroll down. There we go. So this is a very, very common question which we are not going to let fool us. Now, what I want everybody to know is that this right here is what we call a segment. So, and let me tell you where it comes from. It comes from the 2D shapes that we talked about. Okay, because you need to see where everything comes from. Right. On the 2D shapes that we talked about, remember we have 3D shapes, which are the containers. We are not interested too much in them right now. We'll talk about them a little bit. But we have 2D shapes. And for our 2D shapes, these are the plain shapes, the simple shapes. Okay, plain shapes. On them, remember, the first thing we did was we talked about the 3 types of triangles that you'll be given and asked to find area. Right angle triangle, where you have base, you have height. And your area will be base times height over 2. Then we talked about this second triangle, which does not have a right angle. Okay, after this one, you talk about the second one, which does not have a right angle. And we say this is the base. Sometimes you're given the base and the height as well. If they give you the height like this is the height. So if you were asked to get area for here, it is still the same formula. Base times height over 2. Why? Because you have the base and you have the height. The third way to find area is they'll give you this side, they'll give you this angle, then they'll give you this other side. The triangle has no right angle. Nowhere where it says it has a right angle. So they give you those two sides and an angle. The area will be AB, then sine theta, then over 2. So you multiply this one by this one by the angle, but for the angle you bring it with sine, so sine theta. Then you divide everything by 2, just like you divided base by 2 and base times height by 2. Everything is divided by 2. All right, these are the 3 types of triangles that you'll be asked to get area. Then we talked about a circle, we talked about a square, we talk about a rectangle, you talk about a kite. Okay, this is a kite. Then we talked about a parallelogram. These two parallel to this and this. And we saw that to get area, it's almost like for a triangle. You need this height. Then you need this base, this whole base. And you just say area is equal to base times height. Then this and this. This, which I'll put like this, okay? This line which is dashed is your A. Then the one which is dotted is your B. You say area is A times B over 2. These are areas. Now, we have something that we talk about, and this is the sector. It's the one that leads us to segment. We never ever talk about segment, but we talk about sector. Sector is this piece of pizza. What you must know is that this is radius and this is radius, then this is S. And for your sector, you must know that area is equal to half, or we can say r squared theta, because this is theta. You say r squared theta over 2. This gives area of a sector, r squared theta over 2. Then you should know how to get S. S is the arc length, which is the curved one here, this one. S is r theta. Then you must know the perimeter. You must know the perimeter. It's the distance right round the shape. We have an R and another R, and we have an S. So it is 2 R's plus S. This gives the perimeter. So now let's go back to our question. Okay? We go back to the question which we had. Now, here it is. How do we get, that's the biggest question. How do we get segment? How do you get segment? Let me teach you right now. This is a segment, which is what you get when you cut a chord. When you cut a chord, you get a segment. Basically, you have a circle. You just come out of nowhere and you put a line in the circle. This is called a chord. It's a line which does not pass through the center. If it passes through the center like this, it's called diameter, and it cuts your circle into halves. But any line which just passes and does not pass through the center is called a chord, and it makes segments. This one is the minor segment. Then this one is the major segment. Can you see? These are called segments. Now, Here we have been given this thing here, 2.5, which means we can look if we piece our circle together at the bottom, so you see the piece, because what we want is we want to know what piece of the circle, this one which I'm shading, what piece of the circle was it that was removed. That's what we want to know, so that we know what piece remained. But it's a chord, it's a segment, so we cannot know this blue. There's no way of getting area of that blue thing. Nobody taught you how to get there. So how do I get? Well, what you were taught is sector. So segment is all about sector. You were told this one. Right? Students? We know how to get the one in green because it's a sector. So if we can get the one in green, this whole green thing, everything, this one in green, if we can get it, then we remove the triangle in red. Look at the triangle. We will have the shaded region in blue. So we need the whole sector. If I can put it in purple. This whole thing in purple. Then we remove the triangle. Then we have segment. Are we together? Right. Good. Then we will have the segment. So that is what we need. That is what we need, students. Once we have it, we're fine. So let's go for it. Let me take a black thing. Can we find the area? The biggest thing we have to have now is that if you look at, so everybody has seen that we are dealing with sectors. But if you, and then we'll remove this triangle. So there is a triangle. Then there is the sector in black. Now, what we know is that, look here, so that it's easy. If we can have this in this type of triangle here, okay? And if we can have this sector and the formula for area here, then we'll be fine. If we can have the sector and the formula for its area, we'll be fine. So what is the formula for area of a sector? You come to your list and you see it's r squared theta over 2. So I need r and I need theta. What about here? It's a, then b, then sine theta. So I need this side and theta. I need theta. So if we now come to this angle, the a is a radius. This one is a radius, so it's also 2.5. So that means we have a, then we have b. We just need theta for the triangle. For the triangle, we have it, this triangle in black. We need to use AB sine theta. We have A, we have B, the other side. Then what we just need is theta. What about for the sector? What about for the sector? What do we need? For sector, it is what? R squared theta over 2. So R do we have? Yes, it's 2.5. Do we have theta? No. So our biggest job right now is to find theta. If we can find theta, then we will be able to find area of sector and area of triangle and subtract them from each other. If we say sector minus triangle, we will get this shaded region here. Because we have the whole sector, then we will remove the triangle, which is in black, which I'm putting in black. We have the whole sector, we remove the triangle, we will remain with blue. So let's do it. So the most important job we have right now is to find theta. Excuse me. The most important job we have is to find theta. So there is a procedure. What all of you knew. Give me a second. I need to snooze. So let me say this. I know that at the beginning, maths will look hard, right? This is the hardest chapter, by the way. The others are very are nicer. But the more, uh, the more you push, you're gonna get there. Let's keep going. So here it is. Volume of the channel. Let's find. We want segments. So everybody in this class, so that we move on, don't ever forget that there is no such thing as segments. So how we do it is, for us to get this segment, which I'm shading in red, we need to get it. You're going to say, Mr. Clarify, what is the thought process? The thought process is, we need to get this piece that they've removed so that we can remove it from the circle. We need to get the piece, the segment, the small one. The big one is a remainder. We need to get the small one that they've removed. And to get the small one, you first do sector, which I'm showing you, because that's the piece you have. Sector. Everybody knows that sector, piece of pizza. We talk about it. Then you remove triangle, which I'm shading in black. You remove triangle. Everybody knows triangles. So sector minus triangle gives us segment. All right. Let's find theta. So let me show you how you're going to find theta. What you needed was, you needed to use triangles. This is 2.5. This is also 2.5. So because it's the same here and here, if we go down like this, we are halving it. We are halving. So this angle here is going to be, let me open it up so that you can see it. Look, this only happens for an isosceles triangle. If you go down like this, you are halving this angle at the top. So this angle would be theta over 2. Remember, we are looking for theta. So this would be theta over 2. Let me reduce this ink. This one here is theta over 2. Now, for us to do theta over 2, we are going to use the triangle, the right-angled triangle. Now, I'll share a video with you that I was doing in the afternoon with some people. Listen, for a right-angled triangle, once we are looking for an angle, the only time you look for an angle is SOHCAHTOA. So we are going to do SOHCAHTOA. But for us to do SOHCAHTOA, we need two things. For us to be able to look for an angle, we need two things. And the two things we need would be sides. So obviously this one we can't get it. Can we get the height? Let's see if we can get the height. You look around, you look around, you look around. You see this 3 meters. What does it help? 3 meters? Okay. What about this one? From here in blue to the top here. What would it be? Because I know to the bottom is 3. What about here? This would be a radius again, because it's starting at the center and going to the circumference. So it is also 2.5 meters. So in blue, this part which I've put in blue is 2.5. So if you want to find the height, you say this height is 3 minus 2.5. You get 0.5. So you have the real height, 0.5. What does it help you to do? To find theta, so that you can start using the formulas. The formulas are there. They are waiting for us, but we need theta. And how do we get theta? We'll get this theta over 2. This is half of theta. Why we called it theta over 2? We are saying it's half of theta. The real theta is the whole thing here. This whole thing. But we start by finding theta over 2, which is in this triangle. Then we'll get the whole theta. So, let's find it. SOHCAHTOA. We apply SOHCAHTOA to this triangle here. To this triangle in green. So now it's about, do you know how to do SOHCAHTOA? This is theta over 2. This is right angle. This is 0,5. This is 2,5. So for you to do SOHCAHTOA, you write the word SOHCAHTOA. That's part of being good at maths, is to recognize that this is a SOHCAHTOA question. Well done for recognizing it, that it's a SOHCAHTOA. If you have problems recognizing triangles, I'll share with you a video where I was explaining how you can see. Now, once you have recognized that it's SOHCAHTOA, so I should send that video after the lesson so you guys can see. You should label your triangle. So after choosing the method, you label your triangle. This is how we label. Opposite the corner of the right angle is the hypotenuse. Label it. Opposite the angle is the opposite side. The opposite side is the side opposite the angle. Then the third side is the adjacent. So now we have adjacent, we have hypotenuse, we are looking for angle. Good. So which side is not involved in the question? We only need 2 sides. Which side is not involved? This one. O. So that means everything with O we cancel. We only remain with Ka. That's what you write for Cambridge. This stuff which I've been doing, you do with a pencil. For Cambridge, you have chosen to use Ka. So you're going to now say cos theta is equal. Isn't that what Ka means? It means cos theta is equal to adjacent over hypotenuse. Right. What is your theta? It's theta over 2. So you say cos theta over 2 is equal to, what is our adjacent? Here is the adjacent, 0.5. Over hypotenuse. What's the hypotenuse? 2.5. So you get your cos, you are applying now 2.5. Now you get your cos theta over 2. Which means theta over 2, you take cos to the other side. Okay? It will be cos inverse of 0.5 over 2.5. Which means theta, the real theta you want, because this was theta over 2, you take 2 to the other side. It becomes 2 cos inverse of 0.5 over 2.5. So, can somebody press it like this? Press 2, then open bracket, then you say second function, then you say cos. 2, open bracket, second function cos. Open bracket, say 0.5 over 2.5, then close bracket, then close the bracket again. Tell me what answers you are getting. What answers are you getting, students? Clive Bondi, do you have your calculator with you? Mr. Clive Bondi, do you have your calculator with you? Oh, where is your calculator? Who is it that I haven't done with? Sarah, hi. Can you punch this with me, please? Punch it the way you're seeing it there. Sarah, you have your calculator with you, right? Punch and put the answer in the chat, someone. 2.73. Make sure your calculator is not in radians. Make sure your calculator is not in radians. I want an answer in degrees. If you want to remove your calculator from radians, you press the DRG button, this one, until it says degrees. Hi, Kosi. Okay, that answer looks too big. 150 something is a little bit. Wait, let me see. 90. Yeah, it could be correct. It's more than 90, but less than, slightly less than 180. Okay. Remove your calculator from radians. It's correct in radians, Laura. Remove your calculator from, press this DRG button until your calculator at the top says degrees, DEG. Yes, I should get 156.9. Try to do it until you get one. Put the brackets exactly like they are here, but press this button until your calculator says DEG at the top, which means it's in degree mode. Then you do it until you get 156.9 degrees. This is amazing because now we have the angle for all our calculations. Now we can do the calculations. Okay, we have the angle theta. Now we can find area of sector. Now when we are doing sectors, some of you will remember I said when you do sectors, the first thing, this is only for sectors, because now we want area of the sector, this whole thing. Then we will remove the triangle. Then we are going to have the segment. So now we are moving step by step. So we now want for the whole sector in red, this whole sector. Now when you are doing for sectors, make sure your theta is radians. And I taught you how to convert. I said, if you want theta in radians, you say your answer, 156.9 degrees, you divide by 180 degrees, because you don't want degrees. So you divide by 180 degrees, then you multiply by pi rad, because you want rad. So you divide by 180, then you multiply by pi. Can somebody tell me, what is 156.9 divided by 180? What do you get? 156.9 divided by 180, what do you get? Do it and put the answer in the chat for me. Okay, so 0.872 pi rad. Well done. Right. This is it. I love it. So now we have this. Once we have, you know what? The big work was to find theta. Once we have theta, our formulas, we have them. So it's not even a problem. We just say area of sector. So we say area of sector is r squared theta over 2, which is, what is the radius? We look 2.5. So it is 2.5 squared times 0.872 pi divided by 2. Can you please punch this? And since we have been trained, we have been practicing, I told you that when you have more than one thing on the numerator like this, please put a bracket for your numerator terms like it. Okay? Do it. Let's see. Hi, Mr. Alex. At 10. I'll be done at 10. Then we do 45 minutes. I'll be done at 10. Then we do 45 minutes. Yeah. Yeah. I'm live already. Have you seen that? I'm live already. Yeah. Check. Maths. Well, you joined late, so you won't be able to patch it up. Take a nap and then I'll call you. Yeah. Good. Did you? What is the answer? Put it in the chat. Put it in the chat, guys. Put it in the chat. Tell me the answer. Let's go. I want to see several people. I don't want to see some people without calculating. Can you all calculate and put it in the chat? What's the answer going to be? Everybody. Yeah, just punch it exactly like I've written here. Oh, well done. I can see answers coming in. I have active people. I love this. 8.56. So this is like you say centimeters squared. So you've gotten for the sector for the big one. You know that. Well done. Well done. Well done. We have gotten for the sector, right? So now we gotta remove the triangle. Do we have a problem with that? No. So one of the biggest things that why we need to do a lot of questions. Don't put pressure on yourself. You get better at something over time. One of the biggest tricks of this chapter is how you never actually get what you want directly. So what you want, you get it by cutting. Let me show you, for example. Isn't right now we just found the sector. Do we want the sector? No. We are about to find triangle. Do we want triangle? No. So we're going to say sector. Then we cut triangle. We get this segment. We get this segment here. Is it what we want again? No. We get the segment which I'll shade in blue. Let me shade it in blue. We get the segment which I shade in blue. So we get this triangle in red. We remove it from the sector. We get the segment in blue. Is it what we want? No. Why did we get the segment in blue? Because that is the only way we can get this big segment. To get the big segment, we will now say the whole area of the whole circle. We remove the segment in blue. Then we will now have the big segment here. So it's a long journey. Let's find for triangle. Students, triangle, we know formulas, so we are fine. We know what theta is, 0.8, 0.872 pi. 0.872 pi. If you want it in degrees, because we don't actually need it in radians, we can have it in degrees because we are now doing the triangle. 156.9. So it's 156.9 degrees. And this is the other one, 2.5. Now we know the three formulas for triangles, right? We know them. For here, we use half AB sine theta. So we say area of triangle is equal to half of, or we can say AB sine theta over 2. We say this A, okay, if you want to use A and B, it's still fine. You say AB sine theta over 2. Sometimes you see them say half AB sine C. It's the same. We are actually doing the neater way. AB sine theta over 2. What is our A? Our A is 2.5. What is our B? Our B is also 2.5. Then sine of theta. What is our theta? Our theta is 156.9 degrees. Okay? You should be able to do it very well. So for your theta, you say sine 156.9 degrees divided by 2. I hope I'm training you to use the formulas. That's what I'm training you, to use the formulas in hard questions, to trust the formulas. So here, this is going to be what? Somebody please punch. Remember, when you punch, because you have more than one thing in the numerator, put a big bracket, put a bracket, then you now punch everything like this. Another one here, then you say divided by 2 at the end. So tell me what you're going to get. Punch it like the way I've put it there. Tell me what you're going to get. I want to see answers. Sibu, I haven't seen an answer from you. Seth, I haven't seen. Tapelo, I haven't seen an answer from you. Tatayoni, I haven't seen an answer from you. I've seen from Paki, I've seen from Aki, I've seen from Uratile. Dennis, I haven't seen from you. Dintley, I haven't seen from you. Anita, I haven't seen an answer from you. Put in the chat. Put in the chat. What is the answer? Let's go. Be active. Let's be active together. Let's enjoy our classes, guys. Punch this and tell me what you're going to get. Everybody, use your calculator. Let's move. Good. $2.62. Oh, 8.56. Let's see. 2.6. Let's see which ones. Okay, so some got 8.56. Some got. Wait, which one is 8.56? Let me see. Oh, 8.56 is the previous one here. Okay, okay. I now want for this one. Open bracket 2.5, 2.5 again. Sine 156.9 degrees, whatever, divided by 2. 2.62. Okay. So this is 2.62 centimeters squared. Now you say we now have the triangle. So now class, we want area of this minor segment, the smaller segment here. We want it so that we can remove it from the circle. So we will now say area of minor segment. So there is no way. What you have seen today is that, and you tell people tomorrow and everybody, oh, some are getting 1.22. Wow. Okay, so which one is it? 1.22 or 2.62? Let me punch with you. Let's see. Let's see. Let's do it together. 2.5 times sine 156.9 divided by 2. Oh, it's actually 1.23. 1.23. Okay. Guys, check your calculations again. Don't forget to put these brackets. Please, students, don't forget to put the big bracket, this one. Then you open bracket again. You say 2.5 close. You open again, 2.5 close. Sine 156.9. What do you get? You should get 1.22. 1.226, which becomes 1.23. You can even write it as 1.226 because you don't want to round off too much, too early. Here you now say, what you have seen, which you tell people, is that segments have no formulas. The only way to get them, we do sector, then we remove the triangle inside them. So now we have seen that. So we can now get for our segment. We will now say area of segment is area of sector minus area of triangle. You should tell people that. Okay? And you always get the smaller segment. You can't get the bigger one. You always get the smaller one. So this would be, what is our sector? 0. Area of sector is 8.56 minus 1.226. Is it 8.56? So, what do you get? 8.56 minus 1.226. What are we getting? 8.56 minus 1. Give me the answers. 7.334. 7.334. Set. I need to see answers from you, Set. Right, well done. So now, of the major one, area of major segment, which is the bigger one now, this big one, we just have to say circle, the whole circle, which is just pi r squared, minus area of minor segment, minus area of minor segment. So what is the circle? This is the r, so we just say pi times 2.5 squared minus 7.334. What do you get? Punch it like this, minus 7.334. Punch it like this, pi, open bracket, 2.5 squared, then you say minus 7.334. What do you get, everybody? Put answers, put answers, put answers. Good, I can see activity from some people there. Well done. Let me see answers. Huh? Antonisha, Anisu, the guys with A's. I haven't seen answers from you. Lusika. Okay, well done, Kingsley. 12.3. Good, good. I see answers coming. Well done. I want to see different names bringing in answers. Michelle, I haven't seen. Anita, I said I haven't seen an answer from you today. Lusika, same thing. Okay, well done, Anita. I can see now you're participating. Others, please participate. Michelle, you too. Laura, let's go. 12.3. Okay, 12.3. So this becomes area of the major segment. Now remember, when you have area of anything, you can get volume. When you have area, you can get volume. All you need to find is what is the length of the pipe. So here we have found the area. Now we need to find volume. So they need to tell us, now we have the area of the front face. Remember, if I want to find volume of a tube, any tube, you tell them, oh, you want me to find volume of your tube? Yes, please find volume of this tube, whatever, and show us so that we know what we are doing, if it's correct or not, or whatever. You say, okay, if you want me to find your tube, then what I need you to do is, I need you to, here, I need you to tell me the length of the tube. I find area of the front face, area of this. Then I multiply by this length, I'll have volume. It's so simple. Area of the front face, then I multiply by this length, I have volume. So area of the front face times this length gives me the volume. That's the secret for volume. So they need to tell us the tunnel. They said the length of the tunnel is 800. So now they want volume. What was the hardest thing was the area of this tunnel, because it's a weird shape. Now we just say volume of the tunnel is equal to the area times the length. So area of segment times length of tunnel, which is 12.3 centimeters squared times 800. Was it centimeters? Was everything centimeters? Sorry, it was meters. We have been using the wrong units. It's meters. Meters. So everything is meters, so it's times meters squared. Right. So, calculator students. This time I want new face. Let's see. What is the volume? Seth, tell me, put in the chat. You guys, put in the chat. Seth, Dintle, Dennis, Letty, Clive, Bondi. I want to see answers from you this time. What is the answer? And Tataone, I haven't seen an answer from you. Answers in the chat. 12.3 times 800. This is meters. 800 is meters. So again, 9840. All right. 9840. Wow. So we have volume 9840. Right. Seth, I need to see an answer from you. Come on now. 9840. I know you can punch. I know that. 9840 is a good answer. So this becomes the volume of the tunnel. Wow. How many? Look at this, guys. Yes, it's boring. It looks hard and everything, but it's rewarding. It's very rewarding. 9840. So 98, 7 marks. This is very rewarding. I would be the happiest man. In an exam, if I get 7 marks, I'm going to really tell my dad. That's how I do it. Like after my exams, I tell, hey dad, I did very well. So they brought this 7-mark question and whatever. You need to do the same, okay? When you do very well, you should tell your parents, encourage them, make them feel good about the work you're doing. This is amazing. So this is amazing. I'm proud of you. This is amazing. You should tell your parents, your mom, tell your mom, I did this 7-mark question. The nicest part is I know the stages. So that is the nicest part. You know stages. So we're going to be doing these hard questions. And what we are practicing, we know that maybe Cambridge will never repeat this one. But what we know is that the stages, oh, Lusika, the screen is black. Sorry. What we know is that they're going to repeat the stages, students. So Cambridge won't repeat this question, but they will repeat stages like this. So what we are learning is stages. Big stage, like this one. How you get area of minor segment. And how you need theta. How you need theta to do all your calculations. And how to do SOHCAHTOA so that you can find your theta if you're not given. You are learning. How to do area of this, how to do theta, and how to do SOHCAHTOA. SOHCAHTOA to find your theta. How to, for sectors, how you should always have theta in rad for your sectors, and how to convert it to rad by dividing by 180 degrees to remove degrees, and you multiply by pi rad to put rad. All these things, this is practice. They will come in different questions in different ways, but the method will not change. So I'm counting on you. I'm counting on you 24/7. I'm going to go live again a little bit later and do more questions. I'm going to have to. Right. I have some people who are writing maths tomorrow, A-level students. So this has taken us a bit of time, and it's affected the bio lesson. I have to cover up for it. Okay, I'll cover. So this is exam season, so everything is all over the place. But don't worry, we'll return to normalcy soon. I will cover up for bio. Can I do a clip and send it as a video into the group tonight? I can do that, right? Will you allow me, Mazita? All right. So when I say will you allow me, it means that wait, nobody should leave yet. I haven't marked the register. When I say will you allow me, I mean if I send it, you have to watch it. So you must watch it. I'm going to finish the whole chapter. So I'll explain the whole of reproduction. For you to know reproduction, you have to know sexual versus asexual, right? The advantages of each, the advantages of sexual reproduction and the advantages of asexual. Then, so you have to compare those two. After you know that, you go to flowers. So you must know about flowers, the parts of a flower. You should know the 2 types of a flower to say what is an insect pollinated flower versus a wind pollinated flower. You must know that because you'll be now doing sexual reproduction in plants. When you do flowers, you insect pollinated versus wind pollinated. You are now studying sexual reproduction in plants and sexual reproduction in humans. So asexual versus sexual is just for you to compare them. So when we teach you asexual reproduction, we don't really want to focus on it. We're just teaching you so that you can compare them. Then you do the asexual reproduction in plants and sexual reproduction in humans. We'll talk about it, how it happens. Um, where for sexual reproduction in plants, we'll tell you that's the one you actually study. Sexual reproduction in plants. You say what? Sexual reproduction in plants? Yes. It's how you're going to have your pollen in plants. That's how sexual reproduction happens. So you do the two types of uh, sexual reproductions that can happen in plants: wind pollination versus insect pollination. You compare them. This is what you must know for reproduction. You should compare them. You should know the parts of a flower, what is ovule. You should know all this. Then you should do sexual reproduction in humans. Sexual reproduction in humans, which we'll talk about it. When you're done, you do the 4 important hormones and the menstrual cycle, 28 days, and all this, the stages. Then you do STIs, and you're done with reproduction. So I'm going to cover the whole of it. We move with all subjects together. I'll do more questions in math. Math is about questions. So I want you to do for me. It's easier for us if you do it like this. I want you to do for me May June 20 May June 2025 paper 2-1 and paper 4-1. The mensuration questions in that. Paper 2-1 and paper, or just do all the paper 2s for May June 2025. May June 2025. All the remember, I want it in steps like these. And these type of steps you don't get it from a marking key. So I know that you're going to have to remember the things I've taught you. I want it in steps like these that you're seeing me give for you. If you have questions, you ring me and you ask me, and I will help you. We're moving together as a unit. Everybody, thank you, everybody. Hi, Nibra Salah, whatever. Hi. Okay, so I'm proud of everybody. Thank you, everyone on YouTube. Goodbye.